Okay. So, I have a sphere rock. I'll show you an image. I took a photo of it. I don't have it with me. It's at my house rather than my apartment. And so, but I was at my house and I was looking at it because I think it looks sick, right? And so you'll see the image and, you tell me if it's not just like super cool. And so, basically, I'm holding this ball and, um, uh, I'm looking at it, and I just kind of got hit with this thought that the laws of physics are the same inside the rock as outside it in the air. So whether you're inside the rock or outside and just the air surrounding it, the laws of physics are the same. They function the same way, right? This does not mean that inside the rock is not different from outside, and that the various different colors corresponding to different minerals are not different from one another. So just because the laws of physics are the same doesn't mean that you wouldn't notice a difference being in air compared to being inside the rock, right? Just because the laws are the same does not mean that everything behaves the same way within that space. And so, you know, depending on which mineral you're even in, because you'll see on the image, right? There's splotches of red and there's green, and depending on where you are, right? Obviously, it would be different, because if it wasn't different, then it would all look the same, right? And so the behavior there is different, and I just think that this is really interesting because it's such a there's just the difference is just there's such a drastic change between this thin line, and I guess the real question is just like, where is that boundary, like, physically? Because if you kept zooming in, you just keep zooming in, would you ever find where that actual boundary line is, where it crosses from one to the other, right? And from a practical standpoint, you can see, yes, okay, this is the boundary right here, but I'm just saying, like, where is, like, the official changeover from one to the other? And I don't know if it really necessarily exists. That's a side tangent, though. I don't know if that's actually a point that I'm going to make here. And so, if they behave the same, we would see them as the same. This is interesting because looking at this rock makes me feel like I'm looking at a universe that has been frozen in time. It is so cold in this universe that things appear not to change, and yet just outside of it, which the gravitational pull on something trying to escape would be immense, there is air so incredibly different from that which is within. So here's some photos for context. You can see them. So that's the rock I'm talking about. Looks pretty sick, right? And so I have these images of this rock, and that's what I'm talking about, the red and green splotches. So I'm looking at this, it almost looks like there's a mini universe in there, right? Just kind of like swirling around, though. But it's so cold that it's all just basically, it would appear that it's locked in place. But if you were our scale, right, living inside this rock, right? Like if you were to scale our universe down to fit inside this rock, like, imagine just how strong the gravitational pull would be trying to, jump outside this boundary, right? Because just outside this rock, it's air. It's completely different from what's inside. So imagine what would happen if everything you ever knew and ever seen was in this rock. And then it's just super cold in there, right? And then as soon as you found a way to overpower this immense gravitational pull that you would feel trying to escape this rock, right? Then as soon as you pop out, right, imagine what would happen to you. Because the laws of physics are the same, but the conditions are just so drastically different, right? This is like, it's honestly not even comparable to this. Like, it's magnitudes greater of a difference than this, but it's like you teleporting from the surface of the earth out into space, right? You're not going to last very long without proper preparation. And so it would be like that, except like 10 times worse. Because imagine your entire self is acclimated to survive in a very high pressure, high gravity universe, and then you just pop outside of it. You're gonna immediately like you're gonna like instantaneous explosion, because your body evolved in an extremely high pressure system. And what we know about high pressure systems, if you expose it to low pressure, it's going to expand, right? It's going to, and this kind of gets into a talk that I had a while ago talking about if you were to escape our universe, right, you would have to escape time or whatever, right? And if you were to do that, if you were to escape time, you would probably just spontaneously decay and basically explode, right? And this kind of makes sense looking at it from this perspective, because we are so used to such a strong, pressure, basically. If right outside of our universe is air and we're in, solid rock, then our bodies are not built to survive. And any matter that we try and carry out of this universe to protect us is not built to survive. And so that's why I kind of get back into, I was like, I don't recommend you try and escape, because if you do, you're probably just gonna spontaneously go boom, because you have to be pure energy in order to do that. But even if you were pure energy, I don't know if that's enough. But, like I was saying, I think the reason why is because, nothing in this universe is acclimated to those conditions. And so they're just going to fly apart. And this gets akin to our universe is extremely cold and low energy. But if you expose us to going from solid rock into air, right, all of a sudden it's a very high energy system. Energy is there's no longer a reason to have energy be condensed and go, it's just gonna, so yeah. Anyway, I think that's it for this one, actually. Kind of quick, but, yeah. I think that looking at it from this perspective, it's really crazy, but we think that our universe could potentially be in a black hole, but this is what our black hole looks like, right? It's not actually a black hole. We just can't perceive what it actually is. And so if you were to escape, which theoretically you shouldn't be able to, but if we found a way that you could, I wouldn't recommend it. Because I don't know how you would survive. I don't know, you would definitely need some seriously advanced technology. I mean, not that we're anywhere near close. We could barely leave the planet. We're nowhere near escaping the universe. But if we were gonna think twice. So yeah. I don't know. I just thought it was interesting, so I thought I would bring it up. Anyway, peace out.